This is Flip Class Video 4. In this video, we'll talk about Boolean algebra and various different operations related to it. Last week, we talked about 3 different kinds of variables. Integer variable, which stores whole number value, float variable, which stores real number value, and string variable, which stores character string. This week, we're going to introduce a new kind of variable, the Boolean variable. Boolean variable stores Boolean value, and Boolean value is just true or false values. It's either yes or no, 1 or 0, and true or false. Just like any other variable, you declare a Boolean variable by initializing a variable using a Boolean value. In these two examples, you can declare a Boolean variable named x with initial value of true, or a Boolean variable named pass with an initial Boolean value as false. Notice that Boolean value is case sensitive, so the word true and false has the capital letter with its first letter, so it's spelled capital T and then small letter R-U-E, or capital F and then small letter A-L-S-E. Relation operators are similar to the arithmetic operators we introduced last week, such as addition and multiplication. You use relation operators to make comparison between variables and constant values. So you can make comparisons such as if a variable is greater than or less than a variable, or a constant value, or equal to or not equal to, and so on. And the result of a relation operators is a Boolean variable, so it is indicating whether the condition is true or false. This is a list of all the relational operators. There are 6 relational operators allowing you to make comparison of whether two values are equal to, not equal to, less than or greater than, less than or equal to, or greater than or equal to. Here's a couple of examples of how to use relation expression. In the first example, you have a integer variable x with an initial value of 3. So you can make a comparison between a variable x and the constant value by using the greater than operator. Here, you are making a comparison to check whether x is larger than the constant value 2, and it returns a Boolean value of true to you. So when you do the same thing by comparing the variable x to check whether it's greater than the constant value 4, then it returns a Boolean value of false. In the second example, you are trying to make a comparison between a variable x to check whether it is equal to the constant value of 5. Since the value of variable x is 3, is not equal to 5, so the Boolean value returned is false, and this Boolean value is assigned to the Boolean variable status. So when you print out the value of status, the value is false. Another kind of operators is the logical operators. The logical operators use the reserved word and, or, and not. You use logical operator to combine multiple relational operators, and there are 3 kinds of logical operator. The first one is AND. It returns a Boolean value of true if both of the conditions are true. The second one is the OR operator. It returns the Boolean value of true if either one or both of the conditions are true. The third one is a NOT operator. It returns false if the condition is true. It returns true if the condition is false. Boolean algebra is an area in mathematics. It's dealing with mathematical logic. We have another class in discrete math if you are interested in all the mathematics involved in the discrete math. This is the so-called truth table illustrating the relationship between two variables for all the possible logical operators that you can apply to. Last week we introduced the concept of operator precedencies. It is dealing with the priority of which operator you should operate first. You should all be familiar with that because you learn arithmetic in kindergarten, which basically teach you you need to apply multiplication and division before addition and subtraction and so on. But now we have additional operators, the logical operators and the relation operators. How do you deal with this issue of operators precedency on top of all these operators that we learned from last week? This is an updated version of the operator precedencies rules with the addition of the relational operators and the logical operators. So you should now use this priority list to judge which operator should be executed first and each operator should be executed next. Here's a number of exercises you can try on to evaluate the expression using the relational operators and the logical operators. So if you are given that the value of the variable n is 4 and the value of the variable answer is the character y, the job is to determine the truth value, the Boolean value of the expression, whether the entire expression return a value of true or false. Let's try out some of these exercises together. So in the first one, we have this expression, parenthesis 2 smaller than n, and close parenthesis, and a parenthesis n smaller than 6, and then the close parenthesis. So there are 1, 2, 3, 4, 5, 6, 7 operators in this whole expression. According to the precedencies rules, the parenthesis has the highest priority, and there are 2 pairs of parentheses. And according to the precedence rules, left operators has a higher precedency than the right operators. That's why we evaluate the left side operations first. So the first task is to evaluate whether 2 is smaller than n. Since the value of n is 4, so 2 is smaller than n, 2 is smaller than 4 is true. So the left-hand side return the value of true. Next, you can evaluate the right-hand side. So the value of n is 4, so 4 is smaller than 6. So the right-hand side is also returning a truth value of truth. Now you can evaluate the middle term, which is the n logical expression. True and true is true according to the truth table. So the entire expression returns the Boolean value of true. You can actually test this expression in Python. So basically you initialize a variable n with an initial value 4, and then initialize the value of a variable a and sw with the initial value of a character y, and then you just type in the expression 2 smaller than n and n smaller than 6, and then you will see that it will return a Boolean value of true to you. So I'm going to leave the rest of the expression for you to try it out yourself. Try it out with paper and pencil first, and then you can type it in on Python and then get the answer, and then you can verify the answer to see if you got the correct answer or not. During the lecture, we will be using this Boolean algebra expression to construct a program in branching and making decision operations. So I will see you in the lecture.